Okay, so the final part of your chapter 2, finally the carbon compounds, is your natural rubber. Alright, so in here you're going to learn about what they call natural rubber, how the differences between natural rubber and also synthetic rubber, and then how can we coagulate latex and how to prevent the latex from coagulating. Alright, so first things first. Okay, you need to know, or hopefully you still remember, what is the meaning of polymer. Alright, polymer is basically a chain, okay, a long chain carbon or long chain molecules, alright, made from repeating units, okay, small repeating units. Okay, so let's say that this is a polymer, okay, this whole thing is a polymer, and then your repeating unit here, this is a monomer, alright, monomer. Okay, the small repeating unit is called monomer. Okay, so protein, alright, if you digest protein in your body, you're going to change it into amino acids. Okay, for carbohydrate, if you eat bread, for example rice, okay, carbohydrates, right, spelling error here, alright, carbohydrates, okay, they are going to change it into glucose, okay, which is the smallest molecule. Right, so basically your body is actually breaking down the polymer into its monomer so that you can absorb the nutrient. Okay, this is the nutrient that we want. Okay, the amino acid and the glucose. Okay, so let's say this is an example of a what they call a protein molecule. Right, a protein. Okay, so each of the monomer here, each circle here is the amino acid. Okay, if this is a carbohydrate, meaning each of this is a glucose. Right, so for rubber, okay, since it's a polymer, basically polymer is a plastic, right, rubbery. Okay, so natural rubber, the monomer, you must know the name, isoprene. Okay, so this is the monomer for rubber. Okay, you must know the name of isoprene. You also must know the structural formula of isoprene. Alright, okay, so isoprene, okay, the molecular formula is C5H8. Okay, so you must remember the molecular formula for isoprene is C5H8. Okay, and then how do we get what they call a polymer is through a polymerization process. Alright, polymerization process is the process where you link all the monomer to become one polymer. Okay, so if you link a lot of isoprene together, you are going to change it into polyisoprene. Meaning now in this case, this is changed. So this one will become polyisoprene. Okay, and then each of the small circle here is the isoprene. Okay, so you need to know the chemical structure of isoprene. Now this is a very special structure because normally when we learn about alkenes, you only learn one double bond in the structure, but in the case of isoprene, they have two double bonds here. Alright, so if you look at the naming, okay, this is first carbon, second carbon, third carbon, and fourth carbon. If you look at the naming, alright, if you look at the back here, that's why here they put 1, 3, okay, to indicate the position of the two double bonds. Okay, one double bond is at the first carbon, the second double bond is at the third carbon. Alright, that's why it's here 1, 3 diene. Diene meaning I have two double bonds. Okay, so you need to remember this one. Okay, diene meaning two double bonds. Okay, alright. Okay, so this is the general name for what they call this is the general name. Okay, IUPAC name. Remember, if they ask you for IUPAC name, meaning is this one, 2-methyl but 1,3-diene. Okay, this is the IUPAC name for isoprene. Okay, and then remember when we talk about polymers, how do we change a monomer from polymer? Is that if you have a double bond in the middle, let's say like this, Okay, this is a monomer. Alright, so when I change it into a polymer, the double bond will break, right? And then it's going to become like this. So the double bond breaks, forms a new bond left and right. So this is the new bond, and then we put in a bracket. Okay, that is normally how we draw for the polymerization process. Okay, and then we put the n here, meaning stands the number of monomer. Alright, in the case of isoprene, okay, if you look, since they have two double bonds, right, meaning same thing, they are going to break left and right. So this one breaks to the left, this one breaks to the right. Okay, same goes for the double bond here, left and right. Okay, so since this one breaks come here to the middle, the first double bond also breaks and comes to the middle. That is why the double bond will be shifted to the middle right here. Okay, so this is the monomer. When they change into a polymer, alright, you need to remember that there is a double bond in the middle here. Okay, they have opened up two new bonds left and right. Okay, so this is the structure for polyisoprene. Okay, and then remember that we have 5 carbons, okay, C5H8. Okay, 1, 2, 3, 4, 5. This one is a side group. Okay, and then 8 hydrogens. Alright, so this is the structural formula for polyisoprene. Okay, remember the monomer and also the what they call polymer. Alright, very important. This one normally they will ask in your exam. Okay, so next is latex. Alright, so latex, this is latex. Okay, this is a rubber tree, and then the white liquid here is your latex. So you're going to learn two things. How do we coagulate latex? Meaning how do we make it into a solid? And how to make it to remain as liquid. Okay, so how to coagulate and how to not coagulate latex. Okay, there are two ways that we can actually, there are two methods here. Alright, so the first one is how do we coagulate latex. Okay, so basically latex, okay, is the milk, right? So this kind of liquid, we call it as colloid. Okay, another example of colloid that you always drink every day in your life is milk. Milk is also a type of colloid. Okay, the meaning of colloid is that if you look, okay, basically in the solution, right, you will have particles, all right, in the solution or in the water. Okay, so technically this is what we call a colloid. All right, so we have particles, okay, floating inside the water. Okay, this whole thing is called a colloid. Right, inside the colloid you have particles floating inside. Okay, if you say solution, right, solution meaning that the appearance is clear, transparent, like water, okay, or sugar water. Okay, that is what we call a solution because it's clear, we can see through. Okay, normally colloids, okay, the appearance is opaque. Okay, opaque meaning not transparent. Okay, opaque. Okay, OQUE meaning it's not transparent. So example is your milk. Okay, meaning inside there are particles floating inside. Alright, now latex is basically rubber particles inside water. Okay, if you see here. Alright, so basically your rubber molecules or rubber particles are the polymers. Okay, your polyisoprene. Okay, now this rubber, this is the rubber polymer here. Alright, and then outside they have a layer as what we call the protein membrane. Okay, now this protein membrane, if you look at the charge, is negative, right? Alright, this protein membrane is negatively charged. Okay, so when these two particle polymers come together, right, they will repel because it's the same charge. Okay, so latex, they don't coagulate naturally, meaning the rubber milk that you see here, okay, after you tap the rubber tree and then the latex flow out, they remain as liquid. Okay, why they remain as liquid or they do not coagulate is because the rubber molecules here outside, the membrane here is negatively charged, so they are repelling. Okay, that is why they do not coagulate. Okay, so if I want to make the latex into a solid, meaning a solid rubber form, how do we do that? We need to neutralize the negative charge outside the rubber molecules. Okay, and how do we do that? Is when we add acid. Okay, so you need to remember this. Coagulate latex, you add acid. Alright, so we are going to use weak acids. Okay, formic acid, ethanoic acid, or acetic acid. Okay, you need to know examples of the acid that you use to coagulate latex. Okay, the first method is when you put in acid, meaning you put the acid on your own. Okay, but another way to coagulate latex is when you leave it in what they call open air for a few days. That is the reason why after the rubber tappers, right, after they tap, they don't immediately collect. They leave it a few days first. So why they leave it a few days is because they want the bacteria to help to coagulate the latex. So how does the bacteria help is that the bacteria is going to release lactic acid. Okay, so if you have lactic acid, okay, revision, what type of ions that we have when you have acids? Hydrogen ions. Okay, if alkali is hydroxide ions. Okay, so theory here is very simple. If I want to neutralize the negative charge, I need to use the positive charge, right? That is why we put in acid to coagulate latex. Okay, because they contain hydrogen ions. Alright, so basically the hydrogen ions will neutralize the charge outside of the rubber molecule, hence allowing the polymer to coagulate. Alright, so you will get a semi-solid latex. Okay, meaning it's still going to be slightly like a little bit watery. Okay, so when you add, so this is the explanation lah. Alright, that I just mentioned just now. Okay, why we put acid in. Okay, because after you put the acid in, okay, the hydrogen ions will neutralize the negative charge. Okay, this is important because you need to explain, alright, how does it work. Okay, basically the hydrogen ions will neutralize the negative charge. Okay, so a neutral rubber, what do you call, molecules, okay, or a neutral rubber particle is formed. Okay, so as you can see here, the hydrogen ions, they neutralize the negative charge. Okay, and then it becomes a neutral rubber particle. Alright, now after it is neutralized, what will happen is that since these are particles, right, meaning they are going to constantly move in the liquid. So as they constantly move, alright, and then when they collide, okay, the protein membrane here will break. So as you break the protein membrane, the rubber particles inside or the rubber molecules inside, okay, can come out and then they can stick together. Okay, so if you look at the explanation here, okay, so the neutral particle no longer repel each other. Okay, so the neutral particles will collide, alright, meaning they will hit each other and then you're going to break the membrane. Okay, so once you break the membrane, the rubber molecules can come out. Okay, the polymer can come out and then they are going to coagulate. Alright, and that is how you coagulate a rubber or what we call latex. Alright, so basically these are the explanation that you need to know when they ask you to explain how does coagulation of latex happens. Alright, so basically I can summarize this like this. So coagulate latex. Okay, you need acid. Okay, so the acid is used to neutralize the protein membrane. Okay, so once the protein membrane is neutralized, alright, meaning when they collide, okay, your protein membrane will break. Okay, and then allowing the rubber polymer to coagulate. Alright, it will be released and coagulate. Alright, so technically that is how and what is happening. Alright, but normally in your essay question you need to give proper sentences. I'm just giving you the roughly the main point here that you need to remember. Okay, just remember that the acid added will neutralize the protein membrane, so they do not repel. So when they do not repel, when they collide, the membrane will break. So the rubber polymer inside can come out, and then they are going to coagulate. Okay, so remember how to coagulate latex. Okay, one is if you add acid on your own. Another is if you leave it on what you call open air, and then you let the bacteria to do its work. Alright, so you need to remember the acid that is released from the bacteria. It's lactic acid. Okay, so that is coagulation of latex. So if I coagulate latex, I use acid. If I want to prevent the latex from coagulating, the opposite of acid is alkali. Okay, so if I don't want latex to coagulate, I'm just going to put alkali. Alright, so the ammonia solution will neutralize any acids. Okay, so for any what you call rubber tappers, alright, if they want to prevent the latex from coagulating after they have tapped the rubber and it's in here, right, what they are going to put in is they are going to put in the alkali. Okay, or they use ammonia solution. Okay, so when they put the ammonia solution in, this prevents the latex from coagulating. Okay, that is if they don't want the latex to coagulate. Alright, so acid to coagulate, alkali to prevent coagulate. Okay, so describe how the presence of an alkali can prevent the coagulation process. So basically it's almost the same, right? Hydroxide ions will neutralize the hydrogen ions produced by bacteria. Okay, so the protein membrane remains negatively charged. Okay, because you didn't neutralize off all the hydrogen ions. So the rubber particles will continue to repel each other, and then they cannot combine and coagulate. Okay, meaning they do not coagulate. Okay, so this is the explanation on how alkali prevents coagulation. So two things: how acid promotes coagulation, and how alkali prevents coagulation of latex. Okay, two explanations you all must know. Alright, so that is it. Okay, the coagulation of latex. Okay, next is the properties. Okay, this one normally is what you call asked in your essays. Okay, they ask you to compare between different types of rubber. Alright, so first you need to know is the properties of natural rubber. Okay, now natural rubber, when you stretch, okay, since this is rubber, right? So of course when you stretch, it elongates, right? Okay, and then it returns back to its original shape once the external force is released. Okay, this is elasticity. Okay, a property of rubber. Alright, and then resistance to oxidation. Okay, so natural rubber polymers are easily oxidized. Okay, because they have double bond. If you have double bond, meaning you are easily oxidized. Okay, so meaning this one is actually not good. If you are easily oxidized, meaning it is not a good property, because if you leave it in what they call open air and open condition, right, maybe after some time or some while, your rubber, the cone will start to change in its physical appearances, and then maybe it won't be as elastic anymore. Okay, now effect of heat. Okay, when you heat rubber, you know what happens, right? It becomes soft and then sticky. Okay, this is natural rubber. Alright, but when you heat, when it becomes cold, right, it becomes hard and brittle. Okay, now meaning that natural rubber does not do well in extreme condition. Meaning if your temperature changes very rapidly from very high temperature to very low temperature, alright, your rubber is technically going to be spoiled. Okay, because they cannot withstand what they call high changes in temperatures. Key effect of solvent. Alright, basically rubber, natural rubber, they are soluble in organic products or organic solutions. Okay, now these three things are the disadvantage of natural rubber. Okay, they are easily oxidized, they do not withstand extreme condition, and then they are not resistant to certain solvents. Okay, therefore natural rubbers, okay, the uses are very limited. Okay, we don't use natural rubbers to produce what we call daily life products. Okay, because they are not good enough. Okay, so since they are not good enough, what we do is we make it better. Alright, and how we do that is through a process called vulcanization. Okay, you must know the name of the process. Alright, vulcanization of rubber is basically we try and make the rubber better. We change the natural rubber into something better. Okay, now for a natural rubber, right, for example your rubber band, if you notice, if you keep stretching, okay, or if you apply a force whereby it extends a certain amount of elasticity that they can withstand, what happens is that the rubber band won't go back to its original position. Correct? So that is the disadvantage of a natural rubber. Okay, because when you overstretch a natural rubber, okay, they do not return to original position. So meaning they no longer have the elasticity. Okay, but we can improve it by vulcanization process. Okay, key point of vulcanization process is we are using sulfur. Okay, basically you mix the natural rubber and the sulfur. Alright, so this is the solution that they are using, sulfur monochloride, okay, in methyl benzene. Okay, know these two things. Alright, so what happens when you do vulcanization? Okay, now if you see here, this is natural rubber, okay, meaning your isoprene. This is your isoprene molecule, right? Okay, what happens is that since we know that this is an unsaturated, easily oxidized, right? So what we do is when we put the sulfur and you heat, you are going to break off the double bonds, therefore produce what we call as a cross link. Okay, now when you produce these cross links, right, it basically makes the rubber molecule stronger and more elastic. Okay, so here you can imagine, for example, if I have particles in this shape. Okay, now when it's like this, right, if let's say if I apply a force, okay, what happens is that the top layer is easily shifted. Okay, so something like this. Alright, so they slide, the particles, or they slide very easily. But if I tie it down with a string, okay, and then when I apply the force, alright, this what they call particles, they are not going to slide easily because the string here is going to pull the two particles together, therefore preventing it from sliding away. And that is the main function of vulcanization. Basically you are linking two different layers or two more or a lot of different what they call layers of polymers so that it becomes stronger. Alright, so if you see here, the sulfur atoms form cross-link. Okay, basically like you form a bridge, okay, between molecules. Okay, and then they prevent the polymers from sliding. Therefore, if I can prevent them from sliding, meaning that when I apply the force, right, okay, what happens is that they are still going to be pushed over, but because I have a string attaching to the particles, the string is going to pull back. so that it can return to its original shape. Something like that. Okay, so that is how the vulcanization process helps to maintain the elasticity of a natural rubber. Alright, that's the advantage of a natural rubber basically. Okay, so you need to know okay, the differences between natural rubber and vulcanized rubber. This is normally in your essay questions, 10 marks. They will ask you to compare. Right, so you need to compare in terms of elasticity, strength, and resistance to heat and oxidation. Alright, so natural rubber, if you compare to vulcanized rubber, this is less elastic. Okay, because they can slide over one another easily. This is more elastic because the sulfur cross-link. Okay, we always use this term, sulfur cross-links. Alright, they prevent the molecules from sliding over. Okay, so that is the elasticity comparison. Alright, strength. Okay, alright, natural rubber are weaker and softer. Okay, and then when you stretch beyond the limit, okay, the polymer chain will what? Break. Alright, this is stronger. Okay, vulcanized, they are stronger and harder because of the sulfur cross-link. Okay, we always use the term sulfur cross-links. Okay, in terms of resistance to heat, okay, they cannot withstand high temperature. Okay, they melt very fast. Okay, vulcanized rubber, they can withstand higher temperature. Okay, because of the sulfur cross-link. Alright, so it is more difficult to melt compared to natural rubber. It will still melt, but at least it's better than natural rubber. Alright, okay, easily oxidized by oxygen. Okay, because you have many double bonds. Alright, here no more double bonds because we already vulcanized it. Okay, because the number of double bonds is lesser since we already vulcanized it. Alright, so we say that vulcanized rubber is better or stronger than a natural rubber because of that. Okay, so these are the comparison between the two that you must know. Alright, when they ask you. Okay, normally this one will be in your essay. Okay, so I believe that is it for the whole chapter. Alright, we are finally done. Okay, fats and rubbers. Okay, so that is it for your carbon compounds. Okay, finally done. It's a big chapter. Alright, so fats and rubber is focused more on application, whereas the homologous series, alkane, alkene, alcohol, esters, carboxylic acid, alright, those will focus a lot on the chemical reactions. Okay, so that will be it for today. See you again next time, and we are going to go into chapter 3, which is redox reaction. Okay, bye.